Good morning, students. I'm taking digital system, and this subject is belongs to computer science engineering third semester. In previous lecture, we have started about the combinational circuit. Now I'm taking another part of the combinational circuit, that is a full adder circuit. In previous presentation, we have discussed about the full adder half adder circuit. There are some drawbacks in the half adder circuit. So as to overcome all these drawback, we have designed full adder. So full adder is a combinational logic circuit that can add two binary digits and a carry bit and produces a sum bit and a carry bit as output. So full adder circuit is that type of the combinational circuit which can perform addition of 3 bits, that is 2 binary digits and a carry bit. In other words, a combinational circuit which is designed to add 3 binary digits and produces 2 outputs, sum and carry, is known as a full adder. Thus, a full adder circuit adds 3 binary digits where 2 are the input and 1 is the carry forwarded from the previous addition. The addition of 3 bits is not possible in the half adder circuit. So we have designed a new circuit of the combinational circuit, that is full adder circuit. If we see the block diagram of the full adder circuit, we can see that here are three inputs A, B and C in, containing two output S and C out, where S is used to store the sum and C out is used to store the carry. Likewise, if we see the circuit diagram of the full adder circuit, we can see that for designing a sum, we have same exclusive OR gate that we have used in the half adder circuit. But if we see the C out of the full adder circuit, we can see that here we are using 3 AND gate and 1 OR gate, and the output of the OR gate is marked as C out, which gives you carry out of the circuit. Hence, circuit of the full adder consists of one exclusive OR gate, three AND gates and one OR gate, which are connected together as shown in the diagram. Now let us discuss the operation of the full adder. Full adder takes three inputs, namely A, B and C in, where A and B are the two binary digits and C in is the carry bit from the previous stage of binary addition. The sum output of the full adder is obtained by XORing the bits A, B and C in, while the carry output bit C out is obtained using AND and OR operation. For designing truth table of the full adder circuit, we must have three inputs A, B, C in, and we must have two outputs sum and carry. And the truth table of full adder circuit indicates relationship between the input output variables of a circuit, and the output of the full adder circuit in the truth table were filled by using binary rules. That means if I add 0 plus 0 plus 0, I get this sum 0 and carry 0. If I add 0 plus 0 plus 1, I'll receive sum 1, carry 0. If I add 0 plus 1 plus 0, sum 1, carry 0. 0 plus 1 plus 1, sum 0, carry 1. 1 plus 0 plus 0, sum 1, carry 0. 1 plus 0 plus 1, sum 0, carry 1. 1 plus 1 plus 0, sum 0, carry 1. 1 plus 1 plus 1, I'll get sum 1 and carry 1. This is how we can design truth table of the full adder circuit. Hence, from the truth table, it is clear that sum output of the full adder is equal to 1 when when only one input is equal to 1, or when all the inputs are equal to 1, while the carry output has a carry of 1 if 2 or 3 inputs are equal to 1. Then design K-map for the full adder circuit, as we have total 8 entries in the truth table for the input and the output. So we have to design 8 column K-map for sum as well as for carry. Then mark after designing the K-map, uh, put all the values of the zeros and 1 for the sum as well as for carry. Then write the final equation for sum and carry by grouping the number of ones. But in the above graph, it's not possible to group ones in the sum column. So we are taking 4 ones individually. Likewise, we have to group the number of ones in the carry K map also. So here is the possibility of grouping 3 ones. So the final equation for the sum is A complement B complement C in plus A complement B C in complement plus A B complement C complement plus A B C in, and C out is equals to A dot B plus A C in plus A plus B C in. So these are the two final K-map expression, and these are marked as characteristic equation for the full adder. The characteristic equation of the full adder, that is the equation of sum and carry output, are obtained according to the rules of the binary addition. These equations are given below. The sum S of the full adder is the exclusive OR of A, B and C in. Therefore, sum S is equals to A exclusive B exclusive C in, and the final expression will receive as A complement B complement C in plus A complement B C in complement plus A B complement C in complement plus A B C in. The carry C of the full adder is the AND of A and B. Therefore, C is equals to AB plus AC in plus BC in. Advantages of full adder. The following are the important advantages of the full adder over half adder. Full adder provides facility to add the carry from the previous stage. The power consumed by the full adder is relatively less as compared to the half adder. Full adders can be easily converted into half adder just by adding a NOT gate in the circuit. Full adder produces higher output than half adder. Full adder is one of the essential part of critic digital circuit like multiplexer. Full adder performs operation at higher speeds. The application of the full adders were as follow. Full adders are used in arithmetic logic unit of CPUs of computer. Full adders are used in calculators. Full adders also help in carrying out multiplication of binary numbers. Full adders are also used to realize digital circuit like multiplexers. Full adders are used to generate memory addresses. Full adders are used in generation of program and counterpoints. Full adders are also used in graphical processing unit, that is GPU. At the last, if I conclude this tutorial, we discussed all the key concepts related to full adders in digital electronics. Full adders plays an important role in many digital electronic circuits because a full adder can be used to realize several other critical digital circuit. So student, this is all about the full adder circuit. In the previous presentation, we'll discuss the half adder circuits. Thank you students. Thank you so much.